Let us solve another problem on CDF. So the problem statement is, in a random experiment, a trial consists of 4 successive tosses of a coin. So the random experiment here is tossing 4 coins successively. So if we define a random variable x as a number of heads appearing in a trial, you have to determine the CDF. So in solving the CDF problem, first we have to see the sample space or define the sample space which includes sample points. So the experiment is, you have to toss the coins 4 times, or it is a experiment of tossing coin in a successive manner. The number of times is 4. So in that case, either you will get head, tail in each case. So you have to define the sample space accordingly. So what could be the cases that in all the 4 times you will get all the tails on the coins. So that can be a case, that can be one sample point. So here first case could be that all the coins are tossed and you are getting tails only, and another case is that you are getting all heads. Now next could be that you will get one head in the random experiments of tossing the coins 4 times. So in that case you will get head one time. So head can appear in first toss, second toss, third toss, or fourth toss. So these are the sample points corresponding to one head during 4 tosses. Okay, after that another sample points that you are getting 2 heads. So it can appear like 2 heads can appear at first toss, second toss. First toss, you do the combinations like first toss, third toss, then first toss, fourth toss, then second and third toss, then second and fourth toss, and third and fourth toss. So easy way, this is very easy. Here you write down TTHH, then HHTT, then you place H in the same position and move this H. So this H is moved here, after that this H is moved here. So these two combinations you will get. After that you remove this H. So here T, then H is here. After that you have to move this H to this position. So combinations you can make by any way. Otherwise you know the 16 combinations of binary bits, that is 4 times 0, then 0001, then so this one that is 00000100010, likewise. So these are all the 14 combination 15 yeah, 16 na? 0 to I think 16, 2 raised to 4, 16 combinations. So accordingly you can consider this as a tail, 0 as a tail, and this as a head. So accordingly you can form the combinations. So two heads combination, that means 2 ones could be these. So that is 0011, 0101, and that table, that is almost we know this table, so it is better if you go by that method also. Otherwise, this is also this also you can do. It is easy. This is easy. This is easy. This is somewhat you have to do the combinations, different combinations. Now consider three heads. If there are three heads in the four tosses, so it could be here, it could be here, or HH here, HHTH, or HTHH. So what here we have done, here we have placed for one combination HHH. After that we have shifted it, so it is shifted to here. Then we have again shifted it to H here, again here, HHTH. Then if you do the next circular shifting, then you will get THH. So with circular shift you will get these combinations. Otherwise, again, that digital binary combinations formula you can use, that 0, this is 0 1 1 1, this is 1 1 0, this is 1 1 0 1, then 1 0 1 1, and this is 4 times H. So the sample points you got it as this is one sample point, these are 4 sample points, these are 6 sample points, these are 4, and this is again 1. So these include the included in the sample included in the sample space. So the first step is over, where we have found the sample space. After that, you have to see what is the random variable they have defined. So random variable they have defined it as as the number of heads appearing in a trial. That means you have to count the number of heads in the sample outcome. So these are the sample points or sample outcome. Here you have to count the number of heads in each sample point to define the random variable x. So here number of heads are 0, so that is indicated by x0. Here number of heads are 1, so that is x1. Number of heads are 2, so x2. Number of heads are 3, so x3. Number of heads are 4, so x4. So x can random variable x maps these sample points to these real values. These sample points to these real values. 0 corresponds to this one, 1 corresponds to this group, 2 corresponds to this group, 3 corresponds to this group, and 4 corresponds to this. So this you can write it as x0, x1, x2, x3, x4. So this is the definition of random variable, that it maps sample points to the real values. Now after that, third step is you have to find the probabilities of this random. This is random variable. x0, x1, x2, x3, x4 are the values of the random variable. So you have to find the probabilities of those values. So probability x equal to x0 is probability of sample point t. Okay. So what is the probability of appearing tail is 1 by 2. So 1 by 2 into 1 by 2 into 1 by 2 into 1 by 2. 4 cases, 4 trials. So that is equal to 1 by 16. Now probability x equal to x1. So that is the probability of this set. Now this set's sample points, each sample point's probability is same, that is equal to 1 by 16, because each contains 3 tails and 1 head, and probability of one tail is 1 by 2. Probability of one head is 1 by 2, so that is 1 by 16. So this is each sample point's probability is 1 by 16, but there are 4 sample points, so that is 4 multiplied by 1 by 16, that is 1 by 4. Now probability x equal to x2, same. All these sample points have the probability 1 by 16, but there are 6 sample points, so 6 multiplied by 1 by 16, that is equal to 3 by 8. Then this x3, it has 4 points, so 4 multiplied by 1 by 16, 1 by 4. Then last one is only one single point, so 1 by 16, 1 by 16. So first what we have done, we have formed the sample space. After that we have defined the random variable. After that we have found the values of the random variable, and after finding the values of random variable we have obtained the what are the probabilities of that random variable values. So these are those probabilities. After finding the probabilities of random variable values, we will go to the CDF. So the CDF is found at the random variable values. So fx x naught is equal to probability. So first point is this one. So a trick I am going to tell you, because every time no need to uh, find or say the formula. So fx x naught, you have to take the probability of this 1 by 16, because fx x naught is probability x less than or equal to x naught. Probability x less than x naught is 0 plus probability x equal to x naught, that is equal to 1 by 16. Now fx x1, so finding probability at x1 point, you have to take this 1 by 16 and add the probability of x1. So this x1, that is equal to 1 by 4. So 1 by 4 plus 1 by 16. The formula you know that probability fx x1 is equal to probability x less than or equal to x1. That is fx x naught plus probability x equal to x1. So this is the notation for the CDF. F, then random variable and its value. So fx x2 is, you have to take this 5 by 16 and add the probability of x2, that is 3 by 8. fx x3 you have to take 11 by 16. Previous CDF you have to take and add the probability of that random variable value. So probability x equal to x3 is 1 by 4. So 1 by 4. This is 1 by 4, and probability x equal to x4 is 1 by 16. So fx x4 is, you take 15 by 16, and probability x equal to x4 is 1 by 16. So that is equal to 1. Finally you should get 1. Now how to plot it? So fx x, so at x naught what is fx x? 1 by 16. So 1 by 16. At x1 what is it? 5 by 16. But it is a continuous function, so you have to join this, either it is constant or increasing, so like this. So you have to join this. At x2 what is the value? At x2 it is 11 by 16, so 11 by 16, again join it. At x3 it is 15 by 16, so join it. x4 it is 1, and then it continues. And so before it is 0, before x0 there is no point, so it is 0, CDF is 0, and after that it is, and at the end extreme point it is 1, extreme left it is 0, extreme right it is 1. So this is the CDF graph.